Welcome back, everyone. I hope you had a chance to mingle and recharge your batteries during the coffee break. And we will now continue with this morning's program. We will have a dedicated session on the activities under the Shift2Rail innovation programs. And during the session, we will have 6 speakers. So the challenge for them will be to keep to time. And the challenge for you in the audience will be to ask them interesting questions. So the idea is that we will pause after each program presentation so that you can then ask your questions. So let's get started with our first innovation program, also known as IP1, which is focused on cost-efficient and reliable trains. And to present this, please welcome Program Manager Sébastien Denis.
Thank you, Carol. Good morning, ladies and gentlemen. I'm very pleased to spend the next 15 minutes to introduce you the work that has been done so far in IP1 and the expectation of the community for the open call that is part of the WP 2020. So as you can see, and you will realize it after, at the difference of many of my colleagues, the split of work in IP1 is not done per functionalities, but more a subsystem part, like for example, brake, traction, car body, etc. A short color code, because we will all use the same Gantt chart for the support of our activities. So in violet, this is the actions that are now finalized. In yellow, the ongoing activities. And in blue, this is the activities that are foreseen as part of the WP 2020, either CFM or open call. Okay, so we'll start with the TD 1.1 on traction. So the focus of traction is to provide innovative traction component for energy saving, weight and size reduction, mainly using silicon carbide technology. So far, we have been able to build prototypes that are currently under lab validation, and at the end of the program, we are aiming to have Shift2Rail 7 demonstrator. As part of this benefit, we can already highlight a good expectation of energy reduction for regional platform with a 10% of energy saving. Besides this new traction component, there are also some work that is part of the TD linked to noise and linked to noise. So they have a first simulation tools that is now available in order to estimate acoustic noise and AMI emission, and the results are available at early stage of a development, so a design phase, and thanks to a low computing cost, we can obviously benefit from the work from this simulation to have good design. Okay. Besides that, there are also some work on power semiconductors that are handled on the lifetime model with a high interest on the wearable approach. And it will pave the way for future predictive maintenance algorithm in the next actions. Finally, in 2020, there will be some activities on low TRL for battery and hydrogen solutions that will be launched as part of the CFM. And so it will be some basic research on rolling stock, infrastructure, and operational aspects for retrofitting existing regional trains. So to support these activities, as part of the AWP 2020, there will be one open call dedicated to traction. So the name is Support Development of Next Generation of Traction System. This is an open call of 2.3 million euros that is split in 4 work streams. The first work stream will focus on research on 3D additive manufacturing and new manufacturing technologies for traction components. So the process and technology that will be developed should reduce time and cost for R&D prototypes, but also series and service business should be considered. The second work stream will be based on research on wireless dynamic charging for urban vehicles based on silicon carbide semiconductor. So this is basically to better recharging solution than currently available for the tramway application. Objectives: downsizing the onboard energy storage system, reduction of the demand in peak power, and try to operate with full catenary free. The third work stream will be an investigation on reliability of traction components and lifetime mechanism. So to reach a TRL 4, so basically we're expecting a validated lifetime models in independent laboratory for power semiconductors to be handled. Finally, the last workstream, with an expectation on TRL 4 as well, will be dedicated to research on big data, artificial intelligence, applied to traction system, smart and predictive maintenance. So basically, this is to evaluate the requirement and structure for the data collection, to ease the use of data mining and AI for traction smart maintenance. For TD 1.2, so this is a TD linked to the new generation of train control and management system. So that is using some new concept over wireless technology to make new control function possible. So far, the aim of this innovation is to significantly reduce the number of wires in the train, and it will have a significant impact on the TCMS LCC, installation and maintenance cost. Okay. Also, it will foster interoperability between equipments. So far, two different implementations of functional distributed framework has been achieved. So this is a combination of logical and physical elements. And based on this framework, we are now able to support the deployment of new concepts, such as functional open coupling or drive-by data, and also the integration of application profile. Shift2Rail 2, for the moment, is currently working on the first one on HVAC application. So by the end of next year, we'll reach a TRL 4.5 for the activities, and at the end of the program, same than for TD 1.1, a TRL 7 is foreseen, ready for market uptake. An open call is foreseen to support TCMS activities. So this is a technical solution for the next generation of TCMS. This is an innovative action for 4.6 million euros, divided in 3 work streams. The first work stream will be focused on antenna installation study to optimize transmission reception in wireless TCMS. So this is to handle consist-to-consist transmission, inter-consist transmission, but also train-to-ground transmission. The second work stream will be on functional distributed framework-related research activities, and that will have to include subsystem function adapted to application profile. So the activities are foreseen to reach a TRL 6 for this work stream. And finally, a set of safety and cybersecurity studies, methodology, and tools to support SIL4 application for the next generation of TCMS will have to be produced. Okay. Additionally, there is also a development of a set of equipment and tools to support the CFM demonstrator with a quite high level of maturity for this equipment, so up to TRL 6 and 7. On TD 1.3, so we are aiming to produce several demonstrators for future hybrid car body shell structure. So Pivot and Mat4Rail that ended this year have delivered material assessment and characterization, and have been performing different tests for manufacturing, showing good results for prepreg solution. So the criteria for this selection has been the structural constraints, the EMC and thermics requirements, and maintenance aspect. So validation of the concept with FEA model with weight reduction of at least 15% have been proved, and this weight reduction will significantly impact the payload of the vehicle, and so then we'll have possibility to increase capacity or bring new function service on board. On TD 1.4, 2 areas of research are foreseen: smart running gear in one hand and running gear performance. Both are aiming to deliver at the end of the program fully validated solution for market uptake. On smart running gear area, Pivot and Run2Rail have been developing so far an initial validation of new sensor system for running gear components for CBM. They also worked on new active suspension system, so that will allow higher operating speed in curves. Regarding running gear performance, methodology to reduce noise and vibration in design have been validated by field test, and there have been some development of Components for running gear using optimized material, design, etc. As an example, the spoke wheel that has been presented in 18 in InnoTrans. So to support these two TD 1.3 and 1.4, there is an open call as well, named Innovative Technology for Car Bodies and Running Gear of the Future, that will be a RIA funded with 2.42 million euros. This open call is divided in two work streams. The first one linked to TD 1.3, so the car body part. And the overall idea is to have inspection methods for new materials adapted for the maintenance in railway environment. And the focus should be on non-destructive methods for composite and hybrid car bodies with development of equipment at prototype level, so reaching a TRL of 4 or 5. The second work stream for the running gear will be divided in two subparts. First one, research and development of new elastometric materials with enhanced lifetime for running gear application. So we're aiming to have a lab validation of the material at component level. And a second area for the development of new journal bearings with enhanced LTC and lifetime, so reaching a TRL 3-4. So the area of research could be the grease, the geometry, or the material of the bearing component. In TD 1.5, there will not be any further activities for the open call. Nevertheless, I would like to share the status with you. So currently, there have been some research on electromechanical brake and high silk electronics. So in order to get rid of the pneumatic pipeline, so it will indeed have a significant impact on the LCC cost of the train. And so far, we have been positioned to provide a prototype for the electronic distributor valve, hardware and software that has been built. Okay. Activities on eco-friendly friction pairing are also handled within this project, and we continue the work that has started in Pinta on the adherence with the wheel slide protection system. Okay. All the topics now are merged in a single CFM that will start in the coming days with Pivot 2. On TD 1.6, on doors and access system, several mock-up of doors leaves based on new materials and architecture have been produced. So the criteria to produce this prototype has been the weight reduction and the acoustic and thermal improvement. And also in the same TD, there have been some research on the accessibility for people with reduced mobility, and one concept has been selected at the end of the assessment process. In TD 1.7 on modularity in use, on the sub-area of interiors, so there have been a focus on modularity in order to have LCC reduction. And so far, a design to cost study conducted to identify the main opportunities to reduce the cost and time to change and enter design has been produced. And there have been also some feasibility studies on several concepts, like the validation of the ultralight seat prototype. On the cabin area, research on full organization of the space, taking into account the evolution of the driver role in the train, will be accelerated in 2020 with the support of the new awarded contract, Carbonine, an open call awarded in 19. Okay. Finally, in TD 1.8, so this is a new TD on HVAC, activities will be launched in Pivot 2, so this year, with eco-friendly HVAC unit based on natural gas. If I summarize what I said about the open call, so as you can see, there will be 3 open calls for covering TD 1.1, 2, 3, and 4. You will find on the right the complementarity projects that are foreseen for these 3 projects. In the scope of each open call, you will find as well a proposed schedule for time alignment with the CFM. So this is indicative schedule, but it's important for you to consider it. And finally, as part of the material of the call, there are mention of public deliverables in the call, so this is important for you to have a look at what has been produced so far in the areas that are mentioned here. So this is all for IP1. Thanks a lot for your attention.
Great. Thank you so much, Sebastian. Thank you. Great. Do we have any questions in the audience on our first innovation program? Or any of the topics we just heard about there? Not for now. Okay, there'll be plenty of opportunities for questions. So thank you, Sébastien. We will now move on then to our second innovation program on advanced traffic management and control systems. And to present that, we have Léa Paty. Please take the floor.
Thank you. Thank you. Good morning, everyone. So now, after we heard about the trains and rolling stock, we're going to dive into the signaling and advanced traffic management activities that are ongoing at Shift2Rail. Sorry. IP2. IP2 covers all the aspects and topics related to advanced traffic management and advanced train control. It does so around 11 technology demonstrators. The first 4, which you can also see on that slide, cover activities related to signaling and supervision system. It covers moving block, train positioning, virtual coupling, as well as traffic management system itself. 3 others are related to products, so the introduction of automated train operations from GOA 2 up to GOA 4. Onboard train integrity, which is definitely key for the introduction of moving block and moving further to ETCS level 3. And as well as smart connected radio object controllers for the trackside. We have 2 TDs that are transverse and are covering more the processes. So one is how to move from lab testing, from field test to lab testing for all the testing and certification aspects. The second one is the introduction of formal methods to the rail system. Finally, and last but not least, and I will dive into more details, especially for one of them in a few minutes, is how to ensure fast, reliable communication. There we have our first CD on adaptable communication system and how to secure this communication and secure the data protection with the cybersecurity aspects. It's worth noting that it was slightly touched upon this morning during the dialogue between Joseph Doppelbauer and Carlo Borghini that IP2 will provide key building blocks for the upcoming update of the CCS TSI. In the European signaling jargon, we call that the ERTMS game changers. It's the introduction of FRMCS, so the adaptable, the adaptable communication TD is contributing to ATO, moving block, ETCS level 3, as well as train positioning. Sébastien has already introduced the color code, so it's exactly the same. You can see projects that have already been completed, projects that are ongoing, and projects that we expect, or at least topics that are included in our call 2020 for each of those technology demonstrators. I will start with those, unfortunately, that are not included in the call 2020 for the simple reason that they are already covered by ongoing activities, either projects we launched last year or projects that we are launching this month from the call 2019, Shift2Rail 4 being the leader for the CFM project. I'll start with our achievements in a sense in the field of ATO. The last time I presented back in February, I was proud to say that we had issued the specifications for GOA 2. This is still the case. We even took the step further to have them reviewed by the European Rail Agency to have test benches for interoperability testing done at the beginning of the year. And we are now not only updating the set of specifications so that in the next few months we hope the topic is closed and the solution is ready and available publicly, but also this allows us to go for a test campaign in March in the United Kingdom for passenger trains, and in cooperation with our colleagues from IP5 hopefully in June in Switzerland for freight trains. In parallel, we are of course preparing the work for GOA 3-4, to move to full unattended train operations. Our teams are currently delivering, and we are in the final days, to deliver the preliminary specifications for ATO over ETCS up to GOA 4. This includes also the whole use cases, the interfaces, definition, the logical architecture, and the functional requirements, and leading to a preliminary set of specs which will be taken further in Shift2Rail 4 that is just starting now, as I mentioned a few minutes ago. Regarding other TDs, just to briefly mention it, and it was, I think, clearly explained by both Carlo and Giorgio, all of our activities are now moving to a higher TRL. So the explanation in terms of where we stand for the other TDs is very simple. If I take the example of onboard train integrity, we have a full set of specifications ready, and the teams are now moving to developing the prototypes and starting to prepare the field tests that are expected to happen in the next couple of years. For zero on-site testing, the generic communication model is ready to go. This was a key milestone for the TD this year, including a whole set of interfaces developed and detailed up to the level of FFIS. So for those who are experts in this field know what I mean, in the sense that this communication model will be ready for integrating the different prototypes coming from the different suppliers. Virtual coupling. This was the last TD that was launched in IP2. We launched it at the end of last year, and the works are included in Shift2Rail 3 and the open call moving rail. We will reach a very important milestone at the very beginning of next year, beginning of 2020, with the release of the operational scenarios and the release of the core functionalities for virtual coupling. They're currently performing safety assessments in order to see whether the original concept stands as itself, and all of those activities will lead to the delivery of system requirement specifications. It is to be noted that virtual coupling is definitely a transverse TD inside IP2, but not only. We also collaborating with IP1, TD 1.2. This was mentioned by Sébastien, as they have already performed quite a lot of activities as regards train-to-train communication. TMS is also quite a big TD on our end. They also reach quite a lot of milestones this year on the specification side. The big one will be reached, actually has been reached already. It's just a matter of official delivery. The specifications for the integration layer. This integration layer is expected to be used in order to integrate, for exchanging data, and will be used further to integrate the different prototypes that are going to start being developed in Shift2Rail 4. Last but not least, cybersecurity. The same way the activities will continue in the CFM in 2020, like you can see on the slide. Key milestones also reached this year with the delivery of draft security by design standards, as well as a first set of application profiles. So they will take those activities further as well, starting from next year. I will go back just a little bit because I want to mention the three TDs that will be that are included in or will be addressed by the open call this year, and those three TDs are three of the game changers. So ATO I mentioned already, but adaptable communication, moving block, and train positioning are the three TDs that are addressed in the two open call topics included for IP2 in 2020. Adaptable communication system. key milestones also for them regarding the specification work, user requirements, business model, as well as the system requirement specifications. They're all delivered in 2019, so everything is behind us, and this is quite good. They are now moving to prototyping and to preparing the field tests that will start from end of next year onwards. I'd like to mention that there is obviously also a lot of work ongoing in order to align and coordinate, well, not only with ERA, this is a given, but also with other partners that are involved in the preparation of FRMCS. So for those of you who don't know, FRMCS is what is expected to replace GSMR in the ERTMS specifications in the future. So our teams are also very much active in leading this work, most notably with UIC. Moving block, the same way, the set of specifications has been delivered. This includes obviously the SRS, but this includes also a first draft of operational and engineering rules. This is quite important because now that we are talking about fully specifying ETCS level 3 in the regulation, or at least in the specifications, we're also discussing about possibly harmonizing the operational rules at European level, at least for ETCS level 3. So RTD has made a first draft and has made a first proposal, which has been circulated with the sector, so ERA and the rest of the relevant organizations. And we expect that the work and the discussions will taken further next year and so until 2022. So the specifications are ready, and now the prototyping work is starting, just like in the other TDs. Last but not least, train positioning, a very key topic as well for us. In the same way, they also have delivered SRS and specification work at the beginning of this year. They're working, the first work stream was based on the virtual balise concept, but we also have second work stream dealing that will be exploring other type of solutions such as enhanced odometry and the use of different type of other sensors. So it's the same way, train positioning will be moving to higher TRL activities starting from the CFM topic included inside the call 2020. So I can now go to the core of what is included in the call 2020. So we have two topics for IP2 in open call for a total maximal funding of almost 1.7 million euros. Both topics are research and innovation actions, so it means that funding is expected up to 100%. The first topic, which will address moving block and train positioning, has a TRL up to 3 or 4. The second one up to 4 and 5. And the second topic will address the adaptable communication TD by providing key information. I will get back to that in a few seconds. To be noted, both projects are expected to be not only complementary to the CFM, to the members project of 2020, but also to Shift2Rail 3, which was launched exactly a year ago in December 2018. So the first topic will address moving block and train positioning. For the first work stream on moving block, it's very straightforward, but a key activity we expect the open call to perform on creating semi-model formal models of the specifications of the moving block specifications that have been delivered by the members project in order to have an assessment specifically on the safety side on whether or not the specifications are clear and whether they are non-ambiguous, and see whether we have additional hazard that are coming out of the specifications. We also expect this work stream to do exactly the same type of activity, but for specifications that have not yet been released, specifications on future moving blocks. future moving block, meaning that the teams are allowing themselves to think outside of the box, outside of the current boundaries and constraints of ETCS, ERTMS. We have specifications ready next year with the idea that this open call is also working closely with the members project on that. The second work stream will deal with train positioning by also contributing to a quite extremely important work stream on providing a definition and the development of a railway fault detection and exclusion algorithm. Your role, it means that we know that the applying GNSS for rail is, for ground transportation, at least before rail, is quite a challenge in terms of ensuring that your positioning is actually reliable and safe. So we need to have extra activities in this specific domain. This workstream also includes the definition and development of data fusion algorithm. Here we're also talking not only about the virtual bias concept, but also about the inertial measurement units, kinematics, and digital maps. So we're really expecting this workstream in the open call to work fully with the TD and not only with the virtual bias workstream, not only with the enhanced onboard localization workstream inside the TD 2.4, but really to work with both of them, because the solution that will be provided will be essential for both of them. The idea of this open call is to go up to the proof of concept and with tests and assessments, and also to contribute to the railway minimum operational performance standards that exist in other sectors that are still to be created inside rail. Second and last topic, as I said, it addresses the adaptable communication TD. In this case, we have two work streams again. The first one will look into finding alternative communication barriers that could be used by rail. So we know a lot of them. I'm mentioning what GSMR to start with, but at least 4G, 5G, satellite communication, Wi-Fi, and so on. The idea is really to try and look into other type of barriers that could be used to study the characteristics, their performance, and to issue a list of classifications and recommendations. The idea is really to provide different tools and support, decision-making support for member states, specifically also for infrastructure managers, in order to see what type of barriers could be used in the future when they will be replacing GSMR. Also to be noted that Shift2Rail main delivery is an onboard that is capable of communicating with all those communication barriers, so we should not be limited by that. The second work stream, and then I will stop for now. The second work stream will look into a study on the communication protocol. So that's slightly more technical, but we're still at the level of a study to look into the different transport protocol for ensuring the communication characteristics. I'd like to note that this specific topic, and you will see it, but you already see it with the budget that was allocated to it, is quite specific in terms of the activities that are expected to be performed inside it. If you have read the annual work plan, you may have noticed that we put a specific conditions for participation, meaning that we will allow for this specific topic one company from one member state or associated country to participate and submit a proposal, compared to the usual Horizon 2020 rules that specify 3 legal entities from 3 different member states or associated countries. So it's worth noting and worth for you to know. I will stop here. Thank you very much.
Great. Thank you very much, Leah. Do we have any questions on IP2? Yes, over there, please. Is it working?
Hello.
Yes.
Hello, Leah. Thank you very much. I have a question for the IP202. It's a study of alternative bear, but the TRA seems to be very high. And
It's I think we left it fairly open, 4 to 5 for this one in particular. It is labeled as a study, that is correct, but I don't think, based on the activities that we have included in the call, that the TRL is that high, because we're not only expecting paperwork, we were also expecting the bearers to also be tested, in order to be able to have a classification that is not just based on literature or paperwork, but also based on some experiments. Of course, we're not expecting a consortium to test 100 different types, if even possible, but to at least make some choices.
can I have a second question? Is it supposed to have linked a PhD as well in this one? Like in previous
I think it's not excluded. It is possible, yes.
Thank you.
Thank you for the question, and thank you to Leah. So we will now move on to our third innovation program on cost-efficient and reliable high-capacity infrastructure. And to present that, I'd like to reintroduce Sébastien, who will take the floor again. Thank you, Sébastien.
Hi. Good to see you again. Yeah. Long time. Okay, IP3 infrastructure program. So I'm starting with a classic scheme, and basically, even if there are a lot of TDs in this program, we can merge them in 3 ITDs, I would say. So the first one is on optimizing future infrastructure design, so discovering the work that is done on switch and crossing, tracks, and station. The second one will be on intelligent asset management, so covering the TD 3.6 to 8. And finally, a last integrating technical demonstrator on energy management that is not covered this year with any open call. In TD 3.1 and 3.2, basically research on enhanced switch and crossing system and the radically new design is conducted to improve RAMs and reduce LCC of this key component of the railway infrastructure. So far, among the results achieved, I can list, for example, the development of novel switch and crossing locking and motion mechanics. We have also been positioned to specify embedded integrated sensor for switch and crossing monitoring. A whole system modeling framework for switch and crossings based on numeric tools has been produced, so that could enable some simulation regarding the evolution of the geometry, for example. And finally, some recommended techniques and approach for radical switch and crossing concept has been produced, such as, for example, moving vertical blades. For TD 3.4 and 3.3 and 3.4, both are linked to the tracks. In 3.3, this is more focused on the optimization of the current track system, and 3.4 on the new generation of track. Both TDs aiming to improve RAMs and LCC as per the switch and crossing topic. Okay, so several areas of research have been conducted in these 2 TDs. One on material, the second one on maintenance, and also some full concept. In materials, so some field demonstration of new magnetic rail has been demonstrated and has showed some good results in regard to the resistance of the rolling contact fatigue. Some use case for innovative geotextile and feasibility study for smart fiber-based soil reinforcement has been also conducted. And finally, we are also performing some work on the feasibility of asphalt track solution. Regarding the maintenance area, We have been developing some contactless rail defect monitoring system for small defects that are currently difficult to detect. And we have performed some laboratory studies and track observation in order to identify RCF cracks in rails. And then we provide some recommendation for the process of grinding. On the full concept, as reducing maintenance cost is one of the main purposes of ballast-less track system, we are evaluating the possibility of modular hybrid slab track concept. This is ongoing and it will be continued in IntroTrack 2. To support the activity in track area, so there will be an open call named Next Generation Track Transition Zones with 1.35 million of funding. So it will report to TD 3.4, and the overall idea is to smooth transfer between areas of different support stiffness. So this includes locations of abrupt changes of track support, so typically between the main plane line with that abuts the following features, so switching crossing units, under bridge of other structures, or a change of track construction, for example, from a ballasted track to a slab track. Okay? So the consortium will have to provide detailed design and technical specification for the physical transition zone that will be built at full scale by the CFM, and it should include installation, maintenance, and testing criteria. The consortium will have also to validate, also including simulation, the prototypes on a small-scale demonstrator, so at a subsystem level, but also at components level. So the overall idea is to reach a TRL 5 for this open call. On TD 3.5, we are tackling research on proactive bridge and tunnel assessment, repair and upgrade. So we have been divided the work in several work areas. So the first one in the inspection and the monitoring of the tunnels and bridges. So some health monitoring system has been put in place with the use of various distributed sensors, like for example, fiber optic, and it has been tested in operational environment. Okay. Later on, we'll also conduct work with digital image correlation and also tunnel drainage monitoring. Okay. Some work is also done on bridges and tunnel improvement with some laboratory tests that are currently ongoing on new material for drainage pipe. And on bridge dynamics for high speed, we have been positioned to perform several full-scale tests in order to study the bridge dynamics, so including the resonances, the damping, and the bridge-soil interaction. Now, in regards of the intelligent management system, 3 TDs. The first one of the dynamic railway information management system. So basically, this TD is aiming to manage, process, and analyze the data that are collected by the TD 3.7. Okay, so 2 projects ended this year and has been produced some significant work that will be exploited by the new CFM that has been signed early this month. So several use cases covering a numerous of railway assets has been used as supporting study. For example, track geometry, earthworks, and track circuits, etc. And on this use case, we have proceeded with data analytics. So several techniques have been tested, like process mining, anomaly detection, and predictive analytics. On the top of this data analytics works, we have also proceeded with research on integration layer and on the conceptual data model that has been presented this morning. And we have been positioned to build 2 successful prototypes. So the purpose was to transfer property data to the end user through a standard data model. So to support this TD, there will be an open call that is part of the WP 2020, named Technology Development for Railway System Asset Management. So this is RIA action with 1.7 million euros of fundings, okay? And the focus will be on prescriptive analytics. So this is not to provide only a prediction of the future failures, but it's also to provide solutions for preventing and to solve them. So the consortium will have to provide several tools, one of them being a prescriptive data analytic tools to implement a decision support system with man in the loop for YAMS, and the second one, a multi-objective decision optimization tools. Okay. It should have to include at least one railway use case with a sufficiently complete data set to allow prescriptive analytics, because the first actions we launched in this topic have shown that in some cases the data set is not complete enough in order to proceed with data analytics. So this is really an area of attention. The second one, it will have to allow the validation of results from other use cases that will be provided by Into Smart 2. Overall achievement is foreseen at TRL 4.5. In TD 3.7, we are dealing with the monitoring and the monitoring, so basically to collect the data, as I mentioned. So in Into Smart, a large set of cutting-edge specific measuring and monitoring subsystem has been deployed to collect this data from both onboard and wayside assets. So 4 groups of research has been set. So the system along the line for infrastructure asset monitoring, a fixed system for train monitoring, onboard system for infrastructure monitoring, and finally, onboard system for train monitoring. So a large panel of solution has been deployed, like UAVs, satellites, robotic monitoring application, asset digitalization, etc. And the most promising technologies will be further investigated and developed in Into Smart 2. In regards of TD 3.3 on intelligent asset management strategies, some significant work has been done so far in Into Smart 1, and there are 2 areas of research. The first one is on the elaboration and analysis of use cases for YAMS process, which aim to accompany the design of the generic framework. So a number of use cases have been contributed by Shift2Rail partners so far, and that covered a broad range of planning problems in asset management. And all these areas of studies will be further developed in the vertical demonstrator of Into Smart 2. The second area of studies aims to investigate new advanced working solutions, tools, equipment, logistics, and supporting the lean execution of the maintenance processes. And for that, 2 core tasks have been deployed so far. One on the integrated inspection and tamping process, and the second one, a platform for robotic maintenance execution. And this is for this second area that an open call is part of this WP 2020. So this call is funding with 2.7 million euros. And this is on advanced tools and equipment for collaborative robots and wearable machines. So as I said, it will contribute to the lean execution part of the TD, 2 work streams. The first one will be on the development of standalone demonstrator of an improved existing plant. So either a machine or equipment, by integrating robot technology, so ROS, so robot operating system. So this is to move from a normal platform to a collaborative robot. So this aim of the action really will be ready to support future inspection and execution of maintenance action. And the aspect of moving tools and equipment to the place of execution can be also considered in this work stream. Okay? We're aiming to reach a TRL 5.6 for this work stream. And the second work stream will be on the development and validation of a prototype of exoskeleton suitable for outside conditions, which can perform a set of different maintenance tasks. Okay? And as written in the core text, it has to include there's a set of requirements that are detailed or to reach the expected result by the community, and the consortium should have also to include a use case to demonstrate the expected TRL. In the energy part, I will simply mention where we are so far. As I said, there is no open call covering this topic. So on the smart power supply demonstrator, the overall idea is to develop railway power grid in a novel interconnected and communication system. So it will enable improvement and optimization regarding train traffic capacity, energy losses, and reduce the cost. So far, two main achievements. The first one, a basic design for smart control of rail power supply has been delivered. And the second one, a proof of concept for facts in 50 Hz railway system has been produced. And the demonstrator will be further developed in the end of Intus Tempo project. In 3.10, for the smart metering for railway distributed energy resource management system, so we have been in position to develop and apply the concept with two new use cases. The first one on a line in commercial operation south of London, so with two DC substation and a 20 kilovolt AC junction live monitored. And the second use case on a tramway depot in Spain, with traction substation and low voltage cabinet instrumented to send energy measurements. So currently, the data started to be analyzed, and we are expecting to have the first output by Q2 2020. Finally, for TD3.11 on station, the following areas have been covered, so the capacity, safety, and security in large station, using the benefit of digital twins models for simulation as is an ongoing work. The design of small station with the objective of reducing the whole life cycle, the whole life cost and standardized design is also currently ongoing. And finally, on the platform to train accessibility, the Open Call Fair Station has produced a virtual demonstrator in the frame of this TD to facilitate the onboard path of the person with mobility, without mobility. Yeah. So that's it for infrastructure program. I don't know if you have any question. Here, this is a summary of the open call that I detailed before. So as for the previous one, you will see the level of TRL expected, the type of action, and also, important point, the complementarity that is foreseen for this free open call. Thank you.
Thank you very much, Sebastian, for that second presentation. Do we have any questions on IP3 from the audience? Yes, we have one here in the middle. If we could pass the microphone down.
Thanks very much. Good morning. Francisco from ITEC, Spain. This is a general question, not specifically for IP3, but when you have in a specific topic several work streams, are you expecting to receive one proposal per each work stream, or are you expecting several proposals, one per each work stream, with a reduced budget?
Okay. So
thanks.
So indeed, my answer will not cover only IP3, but all the action, and we are expecting the proposal to cover all the work stream of the text. So we cannot propose something when you address only one work stream with reduced budget. You have to address all the work streams.
Great. Thank you once again, Sebastian. Thank you for the question. We will now move on to IP4, dedicated to IT solutions for attractive railway services. And to present that, please welcome Esther Bravo. Thank you.
Hello? Okay. Perfect. Hello. Well, everyone is talking about the future of mobility and to attract people to more sustainable means of transport. And to achieve that, we have to work on interoperability. We have to make railways more interoperable with other mobility solutions. And this is the core of IP4. In IP4, we want to work to make railways more interoperable with every mobility solutions in Europe. So, IP4 is working in a digital ecosystem. It's an interoperable set of services that will provide travelers with the functionality to perform a multimodal travel across Europe. So with a single click, in a single stop shop, travelers will have access to all mobility services from shopping, booking, ticketing, and also to have stored in a cloud wallet all the entitlements for each corridor of the traveler. So, in order to achieve all of these functionalities, we are working in 6 different technological demonstrators. All of these 6 technological demonstrators, we contribute to a single integrated technological demonstrator, which will be the fusion of all the outputs of the different technological demonstrator. So, the first one, which is the interoperability framework, is a platform, is a software platform that through semantic interoperability will allow the different travel service providers to connect to the ecosystem and give access to their services in each region. Because one important thing of this interoperability framework is that it will allow all the operators to connect without changing the legacy system. We are not only focusing in long-distance travel, because for us, multimodality is really important, the first and last mile. As it was previously said, the urban mobility is really important, also railway. So this also for small operators and for small companies and small travel service provider, this TD is really important because without changing the legacy system, they will be able to connect. So the next 4 TDs, from TD 4.2 to TD 4.5, they are working on multimodal services and also to customer applications. These are TD 4.2, TD 4, which is travel shopping, in order to make the best offer available to the customer. Second one is the travel shopping, to book the travel itself. Then the third one is the booking and ticketing, in order to book and pay for the different legs of the corridor of the multimodal travel. And then the trip tracking, to assist the traveler through the different corridors, through the different legs of the travel, and also to manage disruption. In case as a disruption occurs, it will inform the traveler and will make available another possible option for him to reach his destination. So the next one, the business analytic, is part also of the technical framework of IP4, and you know that when all of this travel and all of this data of operator is generating a huge amount of data, and all of this data will be managed by the business analytics. And also, thanks to gathering all of this data and analyzing it, it will provide valuable information not only for the passenger but also for the operators. Another thing that I have not mentioned before is that in the software ecosystem that we are building, there is also a platform for the operators. Operators will be able to connect to what we call the contractual management marketplace, or the operators portal, which is shorter. And in this portal, operators will be able to manage their offer that they are providing in the IP4 platform, but also to create multimodal agreements in order with other operators that are participating that are also integrated in the platform. As I mentioned before, all of the outputs of these TDs that I have explained will contribute to a single and will be fusioned into a single integrated technological demonstrator. And all of the outputs of the different projects will be gathered, and what we need from now on is to demonstrate the value of all of these technical outputs. And this is what the call of this year has to do. So as it was already mentioned, we have to move into higher tier rail. We are developing the technology. We have a really good technical outcomes. Also, we had the first version of the application this year, with 2 projects finalizing this year. We will move on in the technical functionalities that are being developed by the call for members. But we need really to demonstrate that is feasible and that is working. So we need to attract operators and stakeholders from the mobility solutions and from the mobility world to test the functionalities of IP4. And this is our main objective, because this will allow us to move IP4 into a higher tier rail, and also to achieve the market uptake of IP4. So for this year, we have this call supporting the implementation of the IP4 ecosystem. It's an innovation action, so that because it's a higher tier rail, we want to achieve tier rail 6-7, and it has a funding of 2 million euros. So, well, as you imagine, the most important thing of this call is to be complementary to the already ongoing projects that are developing IP4 technologies, and also with the call for members of this year that this will work and will finalize the set of functionalities for IP4. So, I will, this is now, for now, and now if anyone has any questions.
Okay, thank you, Esther. Excellent, thank you very much. Are there any questions on IP4 for Esther at this stage?
Yeah, here.
We have a hand here, yes.
Yeah, hello, good morning. This is Virginia Gomez with Hub Brussels. Could you please elaborate a little bit more on which type and the role of the mobility operators that you are expecting to attract? Thank you.
It's already in the call test, and the thing is that, you know, when we are trying to test this kind of technical functionalities, one of the things that we are lacking is the data from the operator. So first of all, what we're trying to achieve is that the operators participating in the call will provide real data in an operational environment. Also, we want also operators to provide other services that will make the travel more attractive. Also, for example, to provide services such as hotel, tourist info, because one of the functionalities of the travel companion also is to provide to the travelers with location-based experience, based on where the travel is performed, to offer additional services to the traveler through the travel companion. So this is another one. And also, what we are looking also into integration of smart operators. We are looking at long distance travel, but as I said, we don't have to forget the first and last mile. So it is important also to have small operators participating in the call. There are also some KPIs that you can see already in the call, but this is the main scope that we are looking for.
Excellent, thank you very much, Esther. Great, so if there are no more questions, we can swiftly move on, as time is also running a little. We will now move on to activities in the freight area, and to present this, I would like to invite Manuel Espinosa to the stage. Thank you.
Well, good morning, everybody. Looks like this train is running a bit late, but I'm going to make my best to deliver this so we catch up a bit and we can finish on time. So, moving forward, IP5 deals with freight. Freight is a very important part of the railway industry and the railway undertakings. We have framed in Shift2Rail or innovation activities through different technology demonstrators. And you will see, well, I don't know if I'm better switch to this one, no?
Let's see if much better here.
Right, it looks like we have framed this into different technology demonstrators. First one deals with the digitalization, automation. Here we mainly deal with ATO, so we are in very much relationship with IP2 and trying to fulfill automatic train operations for trains in GOA 2 level. Then we've got, as a very important part of this TD, auto-coupling. This is a very important feature because forming trains or forming convoys for freight is something very, very time-consuming, and the auto-coupling is going to really help reduce the lead times and is going to increase reliability. So this is another game changer that could happen for the freight industry. And then we've got here condition-based, just 1 second, yes, condition-based maintenance. It will help somehow have very good information about the different wagons traveling all over the places to know if they are fit to run, and they are going to be also good parameters to know how the maintenance should be done and the life cycle if they need to go through, and of course to reduce the cost by having predictive maintenance. This is TD 5.1. We've got a call for members to finish the innovation activities in this TD, and it's running smoothly, and this new call for members is going to be on a multi-TD proposal. Moving forward, digital transport management deals with something which is very important, and we forget about, well, generally in railways undertakings, which are the marshalling and the yards. So we don't have stations with passengers, we've got goods and we've got wagons, and we need to operate this in an optimum way, otherwise we can really generate bottlenecks and we can be close to not to be able to deliver. No? So thinking about marshalling and yards is very important. And this is the technology demonstrator focusing on. So far we are making progress, and there have been a couple of demonstrators in 2019 in the Swedish demonstrator in Hallsberg, Malmö, with Trafikverk delivering some testing, which was of very much use. Then another important thing for managing the yards and the sidings is to know exactly what is there, because maybe we have things we forget about because of the mass of goods we got. So we have something called the intelligence view gate. So by tagging the wagons, we can identify the load, and we identify where is to, etc., etc. So we really help reduce the lead time on maneuvering and moving that piece of good in the time that is in the marshal yard, no? Which so far is delivering good results, and they expect to deliver some tests next year within the German and Swedish context. Moving forward, T5.3 smart freight gun concept. This is a technology demonstrator that deals with the kind of wagon we should have in the future, no? Focusing very much on weight reduction, which will lead into a better performance energy-wise. The less the weight it has, the less energy we need to move. And thinking about cheap wagons, no? Because it's important to have low cost. The freight industry moves on very low margins, so we need to adapt to be competitive. Then there is another area here where we are working on. It is a very small, or equivalent to a very small TCMS, which is like the kind of box that in a future wagon for a freight, we hold all the parameters necessary to know how that wagon is. For example, it's very important to know mileage. We cannot afford having extremely old wagons traveling all over the network that are prone to crash and generate an accident and destroy the infrastructure, which is very expensive. So these kind of things, having like onboard units, small ones, that can monitor the status and also recall some parameters that are key for the infrastructure manager to know if that wagon is fit to run on a network. Going forward, if I'm able to, okay, yes. New freight proposal systems. This is a really interesting one. There is another call for members that is going to happen, but this one deals with the use of electric power. So this is talking about hybridization, and there is a big opportunity with last mile and operating in yards, especially in ports, or when we're really moving goods where the speed is very slow, and we can really make the most out of hybridization or using shunting locomotives that are only electric. At this point, we have managed to deliver some success testing a lithium-ion battery, and we plan to develop further testing to complete the idea. Finally, TD 5.5, it is a TD that has already finished, but it gives you an idea that this IP5 started with a market analysis, so looking at what were the needs, what were the challenges, and writing more or less certain guidelines on how the IP5 should develop, and this is more or less TD 5.5. So I think I've done it in 7 minutes, so I catch up a bit, unless you have a lot of questions, in which case the train will run late.
Thank you so much, Manuel, and for taking time. Thank you. Excellent. Okay, so Manuel and all the program managers will be available, of course, during the lunch break and in the afternoon sessions if you have any specific questions. But maybe in the interest of time, we will now move on. And I would like to invite Judith Standor to come and join us to talk us through the cross-cutting activities. Thank you.
Good afternoon. Okay, next slide. So I would like to now move on to the cross-cutting activities. So the specificity of this area is not on technology it's not built on technology demonstrators, but on work areas, because in this area we are more focusing on simulation tool, harmonizations, processes, standardization activities, harmonizing standardization activities. So it's not on technology development what you have seen until now. This is also an area which is overarching, so it's not focusing on one subsystem that we have seen until now, so rolling stock infrastructure, but these are areas that are touching all the different subsystems. So we have quite a various activities here. The social economic impact, energy efficiency, noise and vibration. So first now I would like to have a look at the, where we are, what we have achieved so far, and after that we can have a deeper look into the call text for this annual work plan 2020. So with regards to the work area 1, this is the social economic aspect. The first activity was carried out already at the beginning of the program, defining the 4 system platform demonstrators, which is high-speed, regional, freight, and urban application. And with regards to urban, here it's focusing on the metro application. In this year, the attractiveness model has been defined. This is very interesting and very important because due to the demographical changes, due to the urbanization aspect, it's very important to see that how the society is changing and how the different how the passengers' behavior is changing, and adapting our system is very important in order to increase our share in the modal shift or in the multimodal transport aspect. This was also mentioned in the welcoming speech or in the introductory speeches, that if we would like to shift more goods or more passengers to rail, we have to have a more attractive solution, so we have to be customer focused. With regards to this work area, there is also a tender planned in the annual work plan 2020, which is going to focus on the cost-benefit analysis of the JU results, as well as how the migration from the current system should be carried out to achieve the migration of these new innovative technologies that are included in the program. The other work area is the KPIs. So in the Shift2Rail regulation, there are 3 quantitative KPIs defined. And the KPI experts have published the second release of the KPI calculation. Then you can also see it in the annual work plan. So we are fine-tuning the baseline. So now I would say that it's more or less fixed. And then we are assessing on a yearly basis what are the improvements of, with regards to the capacity increase, reliability increase, and the life cycle cost reduction, considering the Shift2Rail technologies that are included in the program. In work area 3, we have various topics. So I wouldn't go into all of them now, especially because there is no open call link to that. But here, an important aspect is the harmonization of processes. And also, we have heard the importance of standardization and modularity. So here in this work area, we have the standardization stream, which has published the standardization rolling development plan, so which is identifying what are the standardization needs needed or that should be available in order these Shift2Rail technologies come quickly into the market. So there is a first set of collection of these standards, and this is also what we have shared with the European Commission recently, because they are contributing to the standardization requirements that will be handed to the standardization bodies in the mid next year. The next area is smart planning. So here we are focusing what has been achieved, that there is a macroscopic simulation tool was developed for network planning. And the first trial of this simulation tool has been done by Deutsche Bahn during this Easter, and this seems that this tool was proven successful. And now in the Plaza 2 project, they are further developing this simulation model in order to include additional features that are not yet available in the first version. Also here, in the I2M part, we are focusing on the traffic management system, but mainly focusing on the freight application. So in IP2, we have the passenger aspect included in CCA. We have, this is the only technology demonstrator that we have in CCA, which is focusing on the freight application for, part of the TMS. The next topic is on energy, noise, and vibration. And these areas are key, especially when we hear about the Green Deal and then moving, shifting goods and passengers to rail, because noise and vibration is also one of the biggest externality of rail. And in order to increase the capacity, sometimes there are political pressure not to do it due to the noise or the vibration impact of new or existing lines. So that's why this externality has to be tackled in order to make rail more attractive and more used in the future. And then in this respect, the open call is going to cover the noise and vibration area. But what we have achieved so far with regards to energy, the energy KPIs that are contributing to the high-level Shift2Rail KPIs has been defined. Also, the Shift2Rail experts contributed to the EN standard on energy calculation of rail rolling stock that has been published in August this year. And the OPEU's energy simulation tool is now available, and it could be accessible also for public. With regards to the noise and vibration, currently there is a project that is was launched in 1st of December. This is more focusing on the exterior noise aspects, but as well as vibration. And this is the project that is going to be the complementary project of the open call that now we are launching. And but I will go into the details of the open call later. The last area that I would like to mention before we go to the open call discussion is on human factor. So there was a study developed recently that is presenting what are the future skills and job profiles that will evolve due to the digitalization and automation and all these new innovations that are coming out from the Shift2Rail program. With regards to the open call, I already mentioned that it feeds into the CFM project that just started 1st of December. So there are two areas that we touch upon. One is on ground vibration, and this is the expectation that it's a prediction tool for ground vibration impacting that is supporting the impact studies during the environmental impact assessments. And then the areas to be covered is development of a frequency-based simulation and vibration prediction tool, including different data aspects related to infrastructure and the rolling stock. The requirement specification is going to come from the CFM project, and also the validation of this tool at the end of the action will be also done by the CFM project. The other area is on auralization and the visualization tool. So this is quite important because this is supporting the perception of humans, how they perceive the noise. On the in a virtual environment. This could help decision makers or authorities to decide before the new tracks or an upgrade of an old track is done, whether the noise mitigation tool or the noise mitigation measures that are applied are sufficient or has indeed achieved mitigation that they were expecting. So here the first auralization and visualization tool has been already presented at InnoTrans 2018 at the Shift2Rail stand. However, in this one would be more a large-scale demonstrator, so covering a larger part. And this would be also with the complementary of the CFM project that just started this month. Thank you very much for your attention.
Great. Thank you so much, Judith. Brilliant. So I think we will now move on as we are approaching the end of the program presentations, but we have just one more for you. So I would like to invite Gorazd Marinic to the floor to present IPX. Thank you very much.
Thank you. Good afternoon. IPX, it's an innovation program dealing with disruptive innovation and exploratory research. The funded activities don't directly contribute to a technological demonstrator. In 2018, Shift2Rail funded 4 projects. FlexRail, forecasting the evolution of key fundamental technologies and technical risks. MVDC, creating a next-generation DC power electrification system, also using renewable sources. B4CM, developing a blockchain-based testbed for rail, and Ter4Rail, investigating new opportunities for innovative research and cross-fertilization from other disciplines. In 2019, we funded 3 projects. starting with Translate for Rail, which is breaking language barriers with IT tools and providing predefined standardized messages for the communication between driver and the traffic manager. The Rails project, which is investigating artificial intelligence for rail automation, predictive maintenance, and traffic planning. And finally, also Links for Rail, a CFM project, which is developing a railway functional system architecture and a conceptual data model following a system of systems approach and also improving data exchange. For 2020, we prepared one topic, innovation in guided transport or Hyperloop. Today, there are many activities across Europe and globally working on, for example, innovative control systems for vehicle-to-vehicle interaction, communication and positioning, for example, in tunnel environments, magnetic levitation, innovative light materials, and energy storage and regeneration. But all this research so far has been fragmented and competitive. So the scope of the call is to address these challenges and to create under Shift2Rail a framework where innovation on guided transport would converge with a focus on safe operation of the future systems. The activity should firstly gather European Hyperloop promoters and innovators to define enhanced concepts of operation and safety cases, to define functional specifications, to define operational conditions, and to create testing methodologies and environments. Secondly, the action should also identify potential transferability and synergies with railway solutions, processes, and procedures in general, and in particular with Shift2Rail innovations, TDs, and IPX activities. The expected impact is to gather relevant stakeholders, to bring clarity on operational concepts and standardization possibilities, and to identify transferability and synergies with railways. And additionally, it should enable structured discussion with policymakers on safety and security, and also enable cross-fertilization from other disciplines and disruptive technologies. Finally, the activity should also encourage exploration of innovative and unconventional ideas. This is a CSA coordination and support action with a funding of 250,000 euros. Short, thank you.
Thank you so much, Garaj, for being so short as well, and to all our program managers for that very informative overview. As I mentioned, they will all be available at the Riverside to take your questions. But now I'd like to invite Carlo Borghini to make some closing words. Thank you.
Okay, I don't want to make closing words, but only to say a few things about the annual plan. The first thing is that Caroline already mentioned it. Opening date, in principle, we have a statement inside the annual plan that is quite cryptic, but we had done it for legal reason. But in principle, it will be open on the 7th of January 2020, and it will be closing on the 21st April 2020 at 5 o'clock Brussels time. So prepare yourself. From this point of view, I would like to also to mention the fact that we have the colleague of RAIL, the Research Executive Agency, who are in particular the unit in charge of the validation of the different parties. So you can have a discussion with them for any type of problem that you have in terms of validation of your entity to participate and to have the necessary aspects. They are here in the corridor, so please follow up. We have focused largely the presentation of the annual plan 2020 on the call, because this will be the first part that will be open on the 7th of January. But there is other two elements that are really important. I think Judith already mentioned the tender for the socioeconomic study. So we have effectively a few tenders that will be launched. One will be launched is expected to be launched early 2020. There is a notice that has been published on the official journal, and it's an overall tender for the strategic support of the Shift2Rail activities, which includes what Judith mentioned about the socioeconomic aspect, the methodology for the measurement of the cost and benefit and the migration plan. So this is, if you go on the official journal, there is a notice that is being published or it will be published in any moment now at the Office of Publication. We have also, as we mentioned before, the prices. So we have a price that we expect to open later on during the year. We need to define the detailed specification for a maximum amount of €500,000 related to the train ID. So this is answering requests from the Commission to have, as I mentioned before, also one single train ID. And we'll have also 3 additional prizes that are related to 3 different specific activities. One is related to an activity of the chair of the Transport Committee of the European Parliament, related to startups in transport, and it will be linked to a full series of activity that will be managed, as I said, by Karima Delli as the chair of the Transport Committee. The second prize is linked to the internal project of Shift2Rail, like we have done in 2018 for the 3 categories of projects that we have. And the third prize will be linked to the Women in Transport activity that we intend to present at InnoTrans. So these are the prizes, but the most important will be the one I mentioned, the first one about the train ID. So the annual plan that we have presented today is not only integrated with the work we are doing now and the work that has been done before already. Some projects are closed, but is also fully integrated on the rest of the activity that we are launching. You will see also in the context of the annual work plan 2020, there are €2 million dedicated to the ERTMS deployment action plan activities, because this is for us a basis on which we can put and build the new technology and solution that we are developing. So look at it. The call will be open on 7th of January. The annual plan is already published on our website, so you can look at it, but look in all the different type of aspects, because we have activities that are not specifically in the call, but are in other chapter, for which there can be also an interest.